If one were to survey air pollution and its effects, obviously one would encounter that there's a large diversity of different forms of air pollution. And a previous video and playlist went through climate change, which perhaps offers the greatest threat. At the college where I teach, Orange County Community College, a number of fellow instructors and myself, we did a series of lectures all on climate change from diverse perspectives. And so this, may prove enriching. And one of the points which I had made in this series, which then is a lead into here, is that air pollution can be dangerous. So climate change, covered a bit more thoroughly in a previous playlist, but just this video, it's a serious topic, but I tried, to make it a little bit lighter by talking about, the zombie terrorists, because obviously terrorist actions are obviously, quite alarming and dramatic, and obviously any loss of life is to be is tragic. And if one were to consider what is the toll of, say, terrorism in the world, in 2014, where there was more terrorism than in a typical year, terrorism was responsible for 32,000 deaths, and that is absolutely tragic. However, if one were then to ask, well, air pollution, and let's say start off with climate change and get into different forms of air pollution, what does that do? Well, as I will pursue throughout this video, air pollution affects far more people and causes far more damage. But when you were to look at perhaps news coverage or, reactions of governments, terrorist is such a specific threat that is so easily visualized, whereas air pollutions and its effect on health and disease incidents and crops and extreme weather, etc. Even though air pollution, climate change here, for example, is affecting far more people, it receives less attention, has less a sense of urgency. And so, although most of this video will focus on other forms of air pollution, how could climate change kill you? Well, climate change worsens malnutrition. 3 million people die of malnutrition and respiratory disorders. This is caused by environmental issues, and climate change will make this worse. And so as we look at the availability of water, I'm not sure why it's doing that, as we look at the spread of disease, as we look at malnutrition, as there are effects on hygiene as water becomes less available, as people are forced to migrate from one part of the world to another because crops are failing or they're famine, then disease incidence will be far higher in refugees. And so if you were to then calculate the number of individuals affected by malnutrition, forcing to move, the failure of crops, we'll be getting to disease incidents, etc. Extreme weather, all right? So when you were to look at when hurricanes become stronger and more frequent, when there is flooding, once again, climate change doesn't cause this. There will be hurricanes and floods, even if the global temperature stays the same. But nevertheless, climate change can certainly make this much worse. And so even if we were to just focus on climate change is a serious cause of mortality throughout the world. And it turns out there are many other forms of air pollution as well. So if one were to ask this very serious question, we care about human suffering, we care about death, and obviously the better we can identify the sources of suffering and death, the better we can address this. Then we could ask the question: how many people are affected by air pollution each year? Now, I just want to introduce this as an idea and then go through, say, nitrogen dioxide, and sulfur oxides individually. But there are chemicals that we can breathe which will make asthma incidence worse, which will increase the risk of heart attack and stroke, which increase the risk of Alzheimer's, can worsen diabetes, has a role in cancer, can increase the cause of preterm birth. And so air pollution is very serious. You might not get that idea because if you look at the major causes of death, heart disease, cancer, injury, lower respiratory disease, stroke, Alzheimer's, diabetes. So if we were to list, what are the major causes of death, these are, you don't see air pollution listed. However, air pollution can certainly worsen all of those conditions. Now, if this seems foreign to you, that air pollution, causing suffering, even death, that's actually a good thing, right? Because I live in the United States, and the United States, starting in the 70s, instituted Clean Air Acts, which then were updated. And it is thought that this has saved $2 trillion, including the prevention of more than 200,000 premature deaths, 200,000 heart attacks, 120,000 emergency room visits, and others. So more people would have died if it weren't for this legislation. As I will get into, you can measure this. When air pollution is worse, hospital emergency room admittance is higher. And so you can simply then calculate based on this, how many people do we think would be exposed to air or suffering given the air pollutants. Now, this is an old idea. Because I am, a bit older, I can say that when I was a child, there was lead in gasoline. Lead is a neurotoxin. But in the 1970s, it was recognized, what's in our air, could have serious effects, perhaps on the brains of children. And so it was banned. It was argued at the time, you can't do that. It will hurt industry. It will hurt car sales. It will do too much damage to the economy. The benefit is not worth the cost. Well, that turned out to be wrong, that the cost was absorbed. Car companies are doing fine, even though catalytic converters add a little bit to the price of automobiles. The amount of health savings, the fact that children are not exposed to higher levels of lead, if every single car is an emitter of lead, there's an enormous benefit to that. Now, throughout the world, it took a while for this to take. So, for example, I lived in Paraguay. And here you can see that the super gas, the deluxe gas, is sin plomo. That means unleaded. Notice that the common gas does not have sin plomo. So when I was in Paraguay, all of the cars were still emitting lead, which is a neurotoxin. And so I use this as an example. Paraguay has banned lead in gasoline since, but there are people throughout the world who experience different levels of air pollution. And so you could then have, a statistic like air pollution is causing, this much, in terms of increased heart attacks and strokes. That may seem unreasonable to you, but that may be because of, say, Clean Air Act legislation, which means that you're breathing cleaner air than most individuals. I had a nephew in Paraguay who tragically died of asthma at a very young age. And it's quite possible that living in Paraguay without Clean Air Act legislation, that this is my nephew Christian who passed tragically. from his asthma. That had there been better legislation which limited the exposure of the air pollutants which worsen asthma, that he might not have died. There are a number of organizations which estimate the number of premature deaths due to air pollution. So I've read different studies. This one says 6.1 million premature deaths. Another may say 5.5 million premature deaths, but it's in the millions. I want to thank a fellow professor of mine for his pictures from China. Some of these are more common in certain countries than others. And so once again, if we were to discuss air pollution, you might be able to line, oh, that's not that serious and a cause of health concerns, but that might be in part because of where you live. But we should appreciate it because, for example, the legislations, including the legislation which, when you vote, you can vote for representation, which either favor more, legislation or less. This certainly has measurable effects. Now, areas which lack clean air legislation, that is where the most premature deaths occur. So I have a couple of videos here that just, ask the question, can air pollution kill you? Yes, it certainly can. And the easiest way to measure this is simply to follow, especially in the summer months where it's hotter, where when is air pollution levels highest, hospitals know that they will have higher admittance levels, more heart attacks, more strokes, more asthma attacks on those days. And so when sulfur dioxide levels go up, that's bad for health. When ozone levels go up, when nitrogen oxide levels go up, when particulate matter goes up, all of these are measurable. Health outcomes are worse. And so air pollution can kill you. And there are serious health issues such as asthma. Asthma is essentially an inflammatory disorder of the lungs. It is excessive inflammation of the lungs, which causes asthma. And many different, individual forms of air pollution, whether it be particulate formation, particulate matter, sulfur dioxide, and nitrogen oxides, etc. This is a problem throughout the world, but the World Health Organization estimates that asthma affects 300 million people. That's about the population of the United States. All right, and about 250,000 deaths occur each year because of asthma. About 8% of the United States, about 20 million people, including 6 million children, are affected. So asthma is a huge health concern. And when I talk about air pollutants, sulfur dioxide will make asthma worse. Nitrogen dioxide will make asthma worse. This video is meant to kind of be an overview. And as you can see in my playlist, I have videos which go through each of these topics in greater detail. Various forms of particulate pollution, as I'll get to, will make asthma worse. And so we often underplay air pollution because when we list causes of death, we list it as heart attack or stroke. But there are often environmental effects which will result in the heart attack or the stroke occurring earlier than it would have. So an individual might have had a heart attack, but they might not have had their first heart attack or their fatal heart attack until years later if it weren't for the air pollution that they were exposed to. So let me just say a few things about diverse forms of air pollution specifically. So nitrogen is in biomolecules. So for example, if you look at what makes up proteins, proteins are made of amino acids. And if you look at all of these purple or pink atoms, that is nitrogen. If you look at DNA, DNA has nitrogenous bases. So because living things have nitrogen in them, then when coal is formed from plant material that doesn't decompose completely, when petroleum forms from marine animals which don't decompose completely, there is nitrogen there. So once again, if nitrogen makes up the biomolecules of living things, then the coal and petroleum, which preserve these the remains of these living things, then have nitrogen in them. And so then when we burn these fossil fuels, whether it be coal for electricity or petroleum, then there are chemical reactions which then create a number of chemicals such as nitric acid and a number of nitric oxides. This has a whole host of effects. So nitric acid can affect plants. It's a factor in acid rain, as I will get to, as acid rain is a separate topic. And then these nitric oxide and nitrogen dioxide, they then promote the formation of ozone and particulate matter. One of the things we often fail to appreciate is just the chemistry of the atmosphere. And by that, once this pollutant is made, it doesn't stay in that form necessarily. There are other molecules in the atmosphere with which it can react. And so therefore, even though this is what came out of someone's car, this is what ends up being produced because of chemical reactions involving this. And so we often forget that. We often forget that there are other molecules which will be generated, just as chemical reactions occur when, sunlight or ultraviolet light hits these molecules. Now, nitrogen oxides, like nitrogen dioxide, in and of themselves, they are dangerous. So in and of themselves, they increase the risk of stroke. They increase the risk of Alzheimer's disease. And so the more nitrogen dioxide you are exposed to, the higher your risk. It will increase people getting asthma, and it will worsen asthma. And many of these air pollutants then increase the risk of preterm birth. One of the biggest risk factors for fetal illness and infant illness and infant mortality is being born too early. Being born too early has a whole host of effects. The best place for a fetus to develop is in utero. And so like respiratory distress syndrome, which claims tens of thousands of infant lives per year, even simply in the United States. This is at its highest incidence among infants which are born early. So obviously then anything which increases the risk of preterm birth then indirectly causes infant mortality, because a percentage of those infants will then suffer the worst effects. And so nitrogen is in fossil fuels. And when we burn fossil fuels, this increases the nitrogen, which is then in the atmosphere. Nitrogen then increases particulate matter and ozone, all of which then worsen health. Fossil fuels also then can contain sulfur, because if you look at methionine here, that yellow atom is sulfur. If you look at cysteine, that's sulfur. So proteins have sulfur in them. And when we burn, so thus when coal was made, for example, there's going to be sulfur in coal. When we burn coal, say for electricity, then this sulfur is released. The same would be true of petroleum. Some coals have higher sulfur content than others. Sulfur can react to form sulfuric acid. Once again, this can then worsen acid rain, as I will get back to in just a minute. Acid rain has so many effects on plants. It's one of the reasons that amphibians are declining. These are frog eggs here in this pond. So acid affects plant growth, wildlife, especially amphibians. It affects fish, as we will see, etc. And sulfur dioxides then cause inflammation of the lungs and then cause a number of health effects in humans as well. So it increases the risk of stroke, can worsen asthma. So not only are you at a higher risk of getting asthma, but then also if you have asthma, the more air pollution you're exposed to, like sulfur dioxides, it will get worse. And once again, exposure to sulfur dioxide can then increase the risk of preterm birth, which then increases the risk of infant illness and infant mortality. So nitrogen oxides can have serious health consequences and can be lethal. Sulfur dioxide can do the same, as can ozone. Now, as we will see, when we talk about ozone in just a little bit, the idea will be that, oh, ozone is a great thing. We like ozone. It protects us from the ultraviolet light, which will cause mutations. All right, so I'll get into this. Yes, ozone high in the atmosphere is wonderful. If there were less ozone, we would have more mutations and more skin cancer. So in just a little bit, ozone is going to be a wonderful thing. But ozone high in the atmosphere is different from the ozone around me now, which I'm breathing. Now, I don't think I'm breathing much ozone now, but if I was in the middle of a city on a hot day, then I could be exposed to ozone because, for example, nitrogen oxides can, once again, undergo chemical reactions in the air, which turn oxygen gas, two oxygen atoms together, into ozone, which is a very highly reactive form of oxygen, in which there are three oxygen atoms together. All right, and so ozone is one of the things that we concern ourselves with. We could talk about climate change, because ozone is a greenhouse gas. There's ozone there. Ozone does absorb heat at certain wavelengths of light, but ozone also then has other health effects. It is one of the reactive forms of oxygen, sometimes called reactive oxygen species, which then can inflame the lungs, cause asthma, but then also be a factor in, say, heart disease. Heart disease is the #1 killer in the world, and the reactive oxygen species, which we are exposed to, then worsens that. Particulates are not individual molecules in the air, they are solid objects. But then the problem is, this includes a whole host of things which can vary in size. So here, just for reference, a fly could maybe be 7 millimeters in size. A eukaryotic cell typically is maybe 1/10 of a millimeter in size or smaller. Bacteria are smaller still, maybe 1,000th of a millimeter. But then there are smaller things like viral particles, and there can be smoke particles, etc. So when we talk about solid things, obviously there are size ranges here, and I put the virus, the bacteria, and the eukaryotic cell there just for reference. Some of the sources of particulate pollution are living things. So for example, pollen in the air can, say, aggravate asthma. Mold spores can be in the air as well. And these can vary in size. These tend to be on the larger on the larger side. But then because some mold spores, vary, that, some are larger than coarse particles, some are coarse particles, there are ultrafine particles. And so the issue is all of this can cause the inflammation of the lungs, and all can have negative consequences on health. The ultrafine particles often can work themselves deeper into the lungs, farther along the respiratory passageways. And so the various causes of particulate pollution, so diesel particles, which can be released into the air from car exhaust, and then those chemical reactions involving nitrogen dioxides can be sources of particulate pollution. And so, as I had said, there are many different causes of particulate pollution. So, many people exposed to air pollution, the worst air pollution is in the home, as I'll get to, because a lot of people cook indoors using, say, coal or charcoal or wood. And so people cooking indoors can find it's a very smoky environment, and this particulate pollution can then increase, their exposures. So for many people, air pollution means what, the cars, the factory, or et cetera, what are producing in the outdoor air. But as I'll get back to, for many individuals, especially those who cook inside the house in poorly ventilated areas, as is the case in many parts of the world, this then is indoor air pollution can be the worst. Fungal spores are a form of particulate pollution. And then getting back to climate change, if an area gets more rainfall, then there can be more fungal spores, more mold, which can then worsen asthma and other aspects of health. And so there are diverse forms of this particulate formation. I mean, there can be volcanoes. In many parts of the world, deforestation is practiced by burning. And so that, to clear fire or to clear areas for, say, cow pasture that fires are set. So in certain times of the year, maybe near, rainforest burning in Brazil or in Indonesia, there can be smoke even going from island to island that, fires on one island are then worsening the air quality elsewhere. Out west in the United States, for the increasing frequency of forest fires. So once again, if climate change worsens the risk of forest fire as it does, this means that those living out west will be exposed to more and more particulate pollution from smoke. Obviously, if you're living in a city or near refineries, there's particulate matter, that's entering the air there. Once again, more chemical reactions occur. So, this material goes into the air where ultraviolet light hits it, where it meets reactive forms of oxygen. And so we could distinguish between what are called primary and secondary pollutants. The primary pollutants are what, say, the factory produced, et cetera. But then you could ask, well, what are about the secondary pollutants, which happen after chemical reactions? When the World Trade Centers were destroyed in New York, then the air quality was horrible to the point where many first responders, many firefighters, et cetera, had to leave their jobs shortly afterwards because of all of the damage done in their lungs from the particulate pollution, which they were exposed to. Right, and so all of these videos will go into this in a little bit more detail. But the big point I'm trying to make is that when we think of causes of death, we think of heart attack and stroke and asthma. We think of maybe terrorism, but we tend not to think of air pollution. Although air pollution is a factor in heart attack and stroke, and Alzheimer's disease and asthma incidence, and thus contributes to far more human suffering and far more human death than perhaps very specific events which are more likely to make the evening news. A couple of other thoughts on different forms of air pollution. One is on ozone. And so this is just going into the size of the particles affects how deeply that they can end up. So and ozone in the upper atmosphere is crucial because it absorbs ultraviolet light. So oxygen gas, as I pointed out, is composed of 2 atoms of oxygen, but it can be struck by ultraviolet rays and then break into individual oxygen atoms. Oxygen atoms can then unite to oxygen gas to form O3, which is ozone. And so oxygen gas can form ozone, but then ozone can react with another free molecule of, or another free atom of oxygen to form now 2 molecules of oxygen gas. So in the atmosphere, oxygen gas is forming ozone and ozone is forming oxygen gas, and about 300 million tons of this cycle per day. So ozone is constantly making oxygen gas, and oxygen gas is constantly making ozone. Now, this occurs in, quote, the ozone layer, but there really isn't an ozone layer. If all of the ozone in the atmosphere were to be condensed, it would form a layer less than about, say, 1/8 of an inch thick around the entire planet. But there's no one place where, this is the level where all of the ozone is. Instead, 90% of the ozone is between 10 kilometers and 50 kilometers above the Earth's surface. So there's lots of gases in the atmosphere. Ozone is just one of them, and 90% of the ozone is within a certain range. The problem then is while ozone is cycling, there are chemicals which humans can add to the atmosphere, which make ozone break down more, and thus will cause a depletion in atmospheric ozone. And so these are important. They were mentioned in climate change because a lot of these are greenhouse gases, but a lot of them have both chlorine and fluorine and are thus called chlorofluorocarbons, or CFCs. These are wonderful chemicals. They've been very useful as refrigerants. They've been very useful for a number of industrial processes. So they're wonderful chemicals. But then there's the downside that they release chlorine. And then this chlorine is a catalyst for the breakdown of ozone. And so the more CFCs that humans produce, the more chlorine will end up in the atmosphere, especially in Antarctica, as we'll see, because the ice crystals in the air can then adhere chlorine, providing an area where it can cause the breakdown of ozone. And so thus, as a result of human release of CFCs, there was less ozone in the air than would otherwise have been the case. And now that means there is less ultraviolet light, which is being absorbed by ozone. Now, more ultraviolet light is reaching the surface. And that then is a problem because ultraviolet light then causes mutations. As I had described in the climate change videos, lots of molecules absorb some forms of electromagnetic energy and reflect others. So the reason this shirt looks red is because red light hits this shirt, but it doesn't absorb red, and the red is bouncing off towards the camera and then towards your eye. And so different molecules absorb different types of light, electromagnetic energy. And that's why there are then these different colors. So the same thing here with this blue shirt. In climate change, one of the issues is which molecules absorb heat. Infrared radiation is a form of radiation. But the issue here is that some molecules absorb ultraviolet light. What we don't want is for ultraviolet light to reach the surface of the Earth, because DNA is one of the molecules that absorbs ultraviolet light. And when it does, it causes mutations, as I'll get back to. And so the ozone, which absorbs ultraviolet light, is thus important because it prevents ultraviolet light from reaching the surface, where it could be absorbed by DNA. Now, something which was warned was that these CFCs destroyed ozone. But these warnings were not heeded and not taken seriously. Although some chemical companies did ban the use of CFCs, say in aerosol cans for, say, hairspray and the like, before there was any federal mandate. And so thus it should be, pointed out that, some industries were very proactive in limiting the harm that their chemicals produced, even without being mandated by law. So they are, to be recognized for that. However, it was then noticed that the levels of ozone over Antarctica were less than expected, that there was, quote, an ozone hole. Now, by ozone hole, remember, there's no real ozone layer. It's just ozone, 90% of it is within a certain area. And then we could measure depletion by percentages. And so the darker the blue region here, that would be more seriously depleted than in the light blue. This changes over the course of a year. Once again, apparently ice crystals cause a site where the chlorine ions can adhere, and then chlorine then catalyzes the loss of ozone. Here in the purple, that's even a deeper loss. And so this was, by the mid-'80s, this was something which was unexpected, that there would be this ozone hole over Antarctica. Now, this was certainly a grave concern, but then it was noticed that ozone was being depleted over other continents well. So, for example, North America didn't have an ozone hole of this magnitude, but nevertheless, there was a depletion in the level of ozone. That meant that now more ultraviolet light was reaching the surface, which was now increasing the risk of skin cancer. As someone who's a bit older, I can certainly attest to the fact that when I was younger, sunblock was not a thing, but rather baby oil and all of these things which would make you tan even more. But then after it was realized the damage that this was doing to the ozone layer, that sunblocks became more important. Now, one of the points I'll make at the very end of this video is that very often an argument is said that you can't protect the environment because the cost to economic growth is just too much. It will cost jobs, and so therefore we just can't do both. And then time after time, this argument has been shown to be false. So earlier I had mentioned the lead argument, where it was said that we can't take lead out of gasoline. But then it was realized, well, we have to, because lead is a neurotoxin. We can't have every car, emitting a toxin which will, damage children's neural development. And the car industry absorbed this, just fine. And in the same way, earlier it was argued that, CFCs are such valuable refrigerants and molecules we use for so many things, we can't ban them. The economic cost would be too great. But it turned out that the economic costs were absorbed. The replacement chemicals were a little bit more expensive than the original ones. But many of the same companies which made the original CFCs, which were causing ozone loss, then ended up making the replacement chemicals. Once again, just to illustrate what ultraviolet light does, if there are two separate nucleotides called thymine, ultraviolet light can then cause them to adhere and look like one single nucleotide. So here is a sequence of the human beta hemoglobin gene. And notice here there are two thymines in the blue T, which are adjacent to each other. And so if ultraviolet light were to strike that spot randomly, it would cause it to adhere. And the next time the cell divided, then it would mistake those two separate nucleotides for one and would then make a change to the genetic code. Here's another pair of thymines. That would then be a mutation. So every time that I'm out in the sun, ultraviolet light does this. Now I try to fix a lot of these errors so that they don't become permanent, but nevertheless, I suffer mutations every time that I'm exposed to ultraviolet light. The less ozone that there is, the more of ultraviolet light hits my skin, and thus the greater the risk of skin cancer. In 1987, a Montreal Protocol was an international agreement to limit CFC production. As you can see by this graph, the amount of CFCs produced rapidly decreased. The developed nations contributed to the replacement costs for developing nations. And so here's an example where, in the best interest of health, that changes can be made, and even on a global scale. And so while there are many things that we are doing that hurt the environment, there are certainly examples of us fixing much of the damage that we have done and acting in our own best interest. I just wanted to end with this point because in 1991, I believe, I was in southern Chile, about as far south as you could get without taking a ship to Tierra del Fuego. And I was on a beach. Now notice it wasn't an especially sunny day and I wasn't sunbathing, etc. But I got a decent burn as a result because this ozone hole over Antarctica was growing each year. And it was reaching the point where now Southern Australia, Southern South America were having problems that they could, measure, on livestock that they had, on fish populations, etc. Now, this problem isn't fixed because many of these chlorine atoms, spend so long in the atmosphere, but it is no longer getting worse, and it is gradually getting better back to the original levels of ozone in the atmosphere. So while one should still be very careful and wear sunblock, the great concern that we had in the 80s that this ozone hole was going to expand, exposing us to more ultraviolet light, that was corrected because of international action and that Montreal Protocol. One other big area of air pollution that I would like to address before I start to wrap up is that of acid rain. So water is made of H2O, but it can dissociate to produce this hydrogen ion and this hydroxyl ion. Now, because if something is pure water, the number of the H pluses and then the OH minuses, they balance each other out. So in a pure water condition, there is no acid. Acid is a measure of these hydrogen ions. And so the measure that we use is a pH of 7, with pH being our acid scale. pH scales measure the number of those red hydrogen ions there. And at a pH 7, what you're really saying, if you care, is that the concentration of these red dots is 0.00000001 moles per liter of water. In a liter of water, there's that many moles, and that small number is 10 to the minus 7th. If you take the inverse of the exponent, that's a pH of 7. Once you start getting more red dots, more hydrogen ions in the water, then the water becomes acidic. So carbon dioxide from the air, for example, can dissolve in water and become carbonic acid. Carbonic acid then becomes bicarbonate and that red hydrogen ion, which can be measured. So, water is going to be slightly acidic under natural conditions just because carbon dioxide from the air can mix with it. But then so too can other chemicals. So nitrogen oxides from, say, the burning of petroleum in cars, sulfur dioxide from the burning of coal can produce nitric acid and sulfuric acid. And these acids then cause acid rain. And so now the pH of rainwater, if nitric acid is added to the atmosphere, if sulfuric acid is added to the atmosphere, is now going to be under 7, all right? And so in the state of New York, where I teach, acid rain typically falls, which is in the pH of, say, 5s or even in the 4s. There have, in some parts of the world, been rainstorms which have essentially been in the 2s. With as acidic as that's incredibly acidic, approaching the pH of some. I had said, there are some pH rainstorms which have actually been approaching the level of stomach acid. Back in the day, before there was environmental legislation and the Clean Air Act, so much acid could be produced that fog could actually be acidic and cause deaths. So, for example, in 1952, an acidic fog in London caused 4,000 deaths. A similar fog in Pennsylvania caused 20 deaths. And so it was recognized that this is a potential health hazard that needs to be regulated. Many parts of the world do not have Clean Air Act legislation. And so acids can then cause acid rain problems, which then not only aggravate asthma and cause human respiratory disorders, but then erode limestone and marble, rusting iron, cause the deterioration of paint, and then have a very heavy toll that they can take on fish. So, for example, the more acid rain which falls, the fewer fish that there are. And so at around a pH of 5.5, which is below the normal pH of most bodies of water at around 6.5, some fish species will disappear. Some are less tolerant to acid than others. Below pH 5.0, most aquatic life disappears, and below a pH of 4.0, a lake is essentially dead. This affects terrestrial life as well, in that the more acid rain there is, the more soils are leached. The more nutrients which are leached from the soil. This changes the populations of the microorganisms, increases the amount of aluminum that plants are exposed to, increases disease. And so the more acid rain that there is, not only are there worse and worse health effects which go along with that, but also environmental effects on crops, on the susceptibility of forests to disease, on fish life, and many other aspects. Now, once again, for the second time, I'd like to point out that while it's often depicted that one must choose between the environment and and economics. If you were to look at the average pH of rain in the state of New York by year, starting in the 1980s, notice that it goes up. So there, there were some points where, it's pH 4.5, 4.7. When it's in the fours, that's because there's acid rain, which is lowering the pH, making it more acidic. Low pHs are more acidic. But here you see the rising pH means that the problem in New York was getting better. This is because with Clean Air Act legislations and switch to renewable gases, a renewable source of energy, less and less coal was burned. And look at sulfate levels, they went down. Because of regulations on car emission, nitrate levels in the atmosphere, they go down. But meanwhile, the US GDP and the GDP of the state of New York has increased. And so, the point is, one can see economic growth occurring at the same time that pollution is being controlled, and that the environmental and health effects of pollution are then decreasing. And so one does not need to choose between the environment and health and, the environment and health on one side versus economics, that they can work together. A couple of other points is that while we often think of air pollution as something in the outside air, for many individuals, the worst air pollution that they are exposed to is what is indoors. So if they smoke cigarettes, that's certainly an issue. If they're cooking on a wood stove inside the house, as is common throughout the world, then the particulate matter inside would be worse. But if you get new furniture or new drapes or new carpets, then, we talk about, a new car smell, et cetera. We know that there's what's called outgassing, that, these fabrics, these materials release gases. Well, many of these gases are toxic. They include known carcinogens such as benzene. We can group them together, calling them VOCs, volatile organic compounds. Formaldehyde is a common VOC. And so they can be a primary source of indoor air pollution even a year after new carpets, drapes, etc. Are purchased. Okay. And so, that point that when we think of air pollution, we don't necessarily have to just think of what's in the outside air. For some people, the indoor air is their primary exposure to air pollutants. So the big picture is air pollution causes serious effects, not only to the environment and to biodiversity, which I can pursue in other videos, but also to human health. So much so that we can, the estimates which look into this conclude that millions of premature deaths occur each year. Some have concluded 5.5 million, some have concluded, over 6 million. But the point is, every year, millions of people who would have lived longer die of a heart attack or a stroke or an asthma attack, etc. And this can be observed very clearly because hospital emergency room admittance is highest when air pollution is highest. The effects, go beyond, mortality. Certainly, this is known to be an effect of premature premature birth, which is a contributing factor to infant mortality. And then there are so many other discussions that we could have. So, for example, the lead, the banning lead in gasoline probably decreased the levels of violence which we notice societally. And if you ask, how could that be possible? Well, lead exposure increases aggression and violence. And so when, each car was turned into, a safer vehicle no longer producing lead. This seems to have had effects. You can actually measure that there was a drop in societal violence shortly after lead was banned in gasoline. Now, you could argue, well, it's this aspect of societal, this economic indicator, et cetera. But one of the best things which seems to correlate with that decrease was the banning of lead in gasoline. And so, you don't have to just be worried about wildlife. If you're worried about, aggression in human societies, air pollution seems to play a role. And so I wanted to, introduce this. We tend not to think of, air pollution, environmental issues as being lethal. Getting back to climate change, for example, the Zika virus spread by mosquitoes is a cause of microcephaly in infants. So if a pregnant woman is bit by a mosquito with the virus, this can now cause permanent changes in the brain formation of her infant and child. And so the point made in this video is that there are diverse forms of air pollution, and that there are serious health consequences to air pollution. And other videos, once again, go through climate change.